We've seen how we can push data through a neural network in the forward direction and calculate a certain output. So this output is a function of the input. I change my input, I get a different output, given the values of the parameters. And what are the parameters we're talking about? They're nothing but the weight matrices that we see in every layer. So now the question is, okay, how do we figure out these weight matrices? How do we get the correct values for these weight matrices? And this is done by a very cool algorithm called gradient descent. And how does gradient descent work? It requires a bit of calculus. We're going to have a separate series just focused on that. But the basic idea is we want to find out how every parameter affects the output. What is the effect of this parameter on the output? If I understand that, I can say, okay, how do I adjust this value so that my output changes in a certain direction? So what I can do is apply my inputs, start with random values of these weight matrices, calculate the output, and determine how good or bad the output is. I have a predicted value, I have an actual value. What is the error out there? And then I use that error to adjust all of the weights that contributed to that output so that I push the output in a direction that the error reduces. That happens in what is called backpropagation. So if we start from the output, we propagate the error backwards. Actually, we don't propagate the error backwards. We propagate the gradient of the error with respect to all of these parameters backwards. And we keep doing this repeatedly. So we apply an input, evaluate the output, figure out the error, propagate that error backwards, adjust all the weights. Apply the next input, repeat. Apply the next input, repeat. Till we reach a point where the output is close enough to the expected output. That's how we train neural networks.